Yeah, hi everyone. So today we are going to discuss regression analysis, which is in Section B of CMA Part 1, coming under the category forecasting. So what is regression analysis? Regression analysis is a way of predicting a value in the future based on two variables and their relationships in the past. So we can say you have to predict sales for the coming year. How you will predict this? So you will analyze what are the factors that is going to impact the value of the sales. Maybe we can say during last 5 years there was a close relationship between the advertisement made and the sales happened. So when there was low advertisements, sales was less. When there was more advertisement, sales was high. So we found that there was a relationship between advertisement and sales. Now you are going to find out what is the type of relationship that we will discuss later in correlation coefficient. What is the type of relationship? Is there any strong relationship, or the relationship between advertisement and sales are a weak relationship? So whatever the relationship is, we will try to find out numerically what's the relationship between these two variables in the past, and we are going to apply that relationship in the future to predict a value for the future sales. Okay, so that's what we are going to do in regression analysis. So it is explaining what is a regression analysis is. Regression analysis is a statistical technique used to understand the relationship between a dependent variable, we can say y, and an independent variable x. So a dependent variable, we can say sales, that depending on advertisement. So here in this case, x is independent variable and y is dependent variable. So it helps us to predict the value of dependent variable based on the values of the independent variable. So we can say we are predicting sales based on advertisement. So here let's say we want to predict sales, which is y, based on advertisement expenditure. So we collect the data on sales and advertisement expenditure for several periods to understand the relationship between advertisement and sales, and this is what we are going to implement in our formula also. But how you will determine this relationship between two variables? For that we will use a statistical technique called correlation, and you have studied this already in the early education, maybe in 12th or your bachelor's first year, second year, like that you studied this already. Using correlation, we will try to understand the relationship between two variables. It can be any variables like sales and advertisement, or maybe like in this example, we will see the relationship between the weight of the people and the blood pressure. Okay, so whatever it is, we have to find out what is the type of relationship existing between two variables. Is it a strong relationship or it is a weak relationship? So by correlation, we can say correlation is a statistical technique used to determine the degree of relationship between two variables. For example, sale of ice cream and outside temperature. We know that these two factors or these two variables are closely related. When the temperature is increasing, sale of ice cream is going to increase, and when it is getting winter, the sale of ice cream is going to reduce. So we can say there is a relationship between temperature and sale of ice cream. So first step in studying relationship between two continuous variables is to draw a scatter plot of two variables to check for linearity, that we will see in the coming slide. So what we will do, in the x-axis we will draw or we will have independent variable, and in the y-axis we will have dependent variable. So we can see this in the coming slide. So we have the data here. The data what we have taken here is weight of the people and their blood pressure. So we took different individuals and we took their weight and we measured their blood pressure. And this is the data you are getting from this action. So we will plot this in a graph and we will see how it is going to look like. So in a scattered diagram, we have the weight and blood pressure here. You can see here, this is the weight and this is the blood pressure. And at each weight, we plot the blood pressure. Every weight, we have the blood pressure here, we can see. Okay, so this we plot in a graph, and then we will draw a line through the middle of all the dots. Maybe this line is not, exactly going through the middle of all the points, but just imagine we have a line that is going through the middle of all the dots what we have. So what we can understand is there is a relationship which is upward trending. That means when the weight is increasing, the BP is also increasing. So we understood that there is a trend. What is the trend, or what is the relationship between weight and blood pressure? When the weight is increasing, the blood pressure is also increasing in most of the cases, we can say. So this way we can find out the relationship between two variables. So the relationship can be a positive relationship like you have it here. When one is increasing, other one is also increasing. That we call it as positive relationship. Or when one is decreasing, the other one is also decreasing. That we call it as a positive relationship. And a negative relationship or inverse relationship, we call it as, so we will consider when in situations like when one value is increasing, the other value is going to decrease. It is in the opposite direction. That is why it is called as inverse correlation or negative correlation. And a perfect negative correlation will be denoted by -1, and a perfect positive correlation will be denoted by +1. Or we can say your correlation value is going to be between +1 and -1. There won't be any value beyond +1 or beyond -1 in correlation. So we will see the examples in the coming slide. And also we can say when there is no relationship, that will be denoted by 0. The correlation will be 0 when there is no relationship between two variables. Now you can see this one. Okay, this is sale of cool drinks and outside temperature, and how they are related. We can say when the temperature is 10, you are selling 1 unit of cool drink. When it is 20, exactly you are selling 2. The proportion of increase is same. When the temperature is 30, you are selling 3 ice cream. Again, the proportion of increase is same. This is what we call it as a perfect positive relationship. We can easily predict the future. When it is 50, we can say you are going to sell 5 units of cool drinks. So this type of relationship we call it as perfect positive relationship. And this can be perfect negative. This is denoted by -1 and this is denoted by +1. So this is perfectly negative relationship. Again, we can say outside temperature and sale of sweater. When the temperature is high, sale of sweater is low. But when the temperature is low, sale of sweater is high. So when one is increasing, when the temperature is increasing, sale is reducing. So we can say this is a negative relationship, and because the proportion of increase or decrease in the values are same always, we can call this as a perfect negative relationship. And the value of this relationship is -1. The next slide, we will see there is a relationship here. Again, outside temperature and sale of cool drinks. There is a relationship, but it is not denoted by a single line, right? So there are values deviating from the line that you can draw between these dots. So this we call it as it is positive. The relationship is positive, but it is not perfect. But there is relationship, which is upward growing relationship. Same like that, you can have negative relationship. It is not perfectly negative, but it is negative. When one is increasing, other one is decreasing. So this we call it as negative relationship. So we can conclude that a perfect relationship will have, a perfect positive relationship will have a value, maximum value of +1, and a negative relationship will have a maximum value of -1. So all other values or all other relationships will be lying in between these two extremes. So negative relationship means it is going to be between this +1 and -1. Even positive relationship, it is going to be in between this +1 and -1. And perfect relationship is equal to +1, and perfect negative relationship is equal to -1. And there is no relationship in this case between two variables, and here the value is 0, or the correlation is 0. There is no relationship. And how we find out this relationship? This we don't have to study for CMA class, but just for you to remind yourself about your degree class or something. This is the formula you can find out. This is the formula by which you can find out the correlation coefficient, or what the relationship between two variables. Okay, here you can see age and weight of students. So what's the relationship? When the age is increasing, weight is increasing. So we can find out the correlation coefficient by using this formula, and this is the method it will be used, but we are not explaining this. And finally you will get a number here, 0.759. It is a positive value, 0.759. So from this 0.759, what we can understand is the relationship between these two variables are positive, but it is not perfectly positive. When it is perfectly positive, that is going to be 1. But it is very close to 1, so we can say it is the relationship is positive, but not perfectly positive. But there is a strong direct correlation. It is close to 1. When it is close to 0, we will say the relationship is very weak. Same like when the relationship is very close to -1, again the relationship is strong but negative. When it is close to 0, again the negative relationship is there, but it is weak. Okay, so that is what we are going to discuss here. The statistic showing degree of relationship between two variables, that is what a correlation coefficient is. It is also called as Pearson's correlation or product moment correlation coefficient. It measures the nature and strength between two variables of quantitative type. So correlation is actually telling you the nature and strength between two variables. And it is denoted by this R, and this R is ranges between -1 and +1, as we discussed in the previous slide. So a positive sign means a direct relationship, and a negative sign means an indirect or negative relationship. So this is discussing about the value of R that is ranging between -1 and +1. This we already discussed. The correlation value is going to be between -1 and +1. +1 or +1 is the extreme, and that is the perfect correlation. And -1 is the other extreme, and that's also perfect correlation, but indirect or negative, we can say. This is direct or positive. And 0 means there is no relationship. So the range between 0 to 1, it is actually telling how is the relationship or the strength of the relationships. When it is close to 0, you have very weak relationship. When it is in the middle, intermediate, and when it is near to 1, it is strong. Same like negative relationship, we can say when it is near to -1, it is very strong, then it is intermediate. When it is very close to 0, the relationship is weak. So you have to remember, -1 doesn't mean that the relationship is weak. -1 means there is a strong relationship, but the relationship is negative. That is what denoted by -1. And we have to remember this also. +1 means that is the strongest relationship, and 0 means no relationship, and close to 0 means weak relationship. Okay, this maybe you will get one-word questions in your exam. You are not going to get question related to how to calculate this and all. That will not be shown, or that will not be coming in the exam. So this is what we discussed. If R is equal to 0 means there is no relationship. When it is between 0 and 0.25, the relationship is weak. When it is between 0.25 and 75, it is intermediate. And when it is between 0.75 and 1, there is strong relationship. And if R is equal to 1, that means there is perfect correlation. And this is discussing about the coefficient of determination, or we call it as R square. Whatever we calculated here as R, we will just find out the square of this. Then we will get something called coefficient of determination. So what is coefficient of determination? This is a number that is telling us how well the independent variables can predict the dependent variable. Or we can say how well you can predict sales from the value of advertisement. So this is what we call it as coefficient of determination. You can say if R square is 0.85, this is an example, R square is 0.85. What does that mean? That means that 85% of the ups and downs in sales can be understood by looking at our advertisement spending. Or we can say 85% of our sales are depending on the ads or the advertisement what we are making, and the 15% of the difference or ups and downs in sales are related to other factors. So when the closer R square is to 1, the better our ad spending predict the sale. If it is closer to 0, it means that ad spending does not really help us to predict the sale. So when it is close to 0, we cannot rely on the value of advertisement to predict our sales. But when it is very close to 1, we can assume that there is a close relationship, and almost 85% of our sales are determined by the advertisement what we do. Okay, so in other words, the advertisement expenditure can predict 85% of the change in sales. The remaining 15% of the variance is due to other factors. Okay, so this is what coefficient of determination. You don't have to do anything, just find out the correlation and you just square it off. So R square is coefficient of determination. So in summary, R square helps us assess the goodness of fit of our regression model. A value close to 1 indicates better fit, meaning that independent variables are more effective at predicting the dependent variables. Also, conversely, the value closer to 0 means it's a poor fit and you cannot rely on the independent variable to predict the dependent variable because the relationship is very weak. So this is what coefficient of determinations. So being understood all these things, now we can start regression analysis. In the beginning I said regression analysis means predicting a future value by incorporating the values or the relationship of those values happened in the past. Okay, so we can see here what is regression. Regression technique concerned with predicting some variables by knowing others. Or precisely we can say it is process of predicting the variable x using predicting the variable y using variable x. So here y we can say sales, x is advertisement. So you are predicting sales by looking at the value of advertisement. So a simple regression equation attempts to measure the relationship between two variables. As we discussed, the variables are one is independent, other one is dependent variable. So regression actually calculates the best fit line for a certain set of data. Calculate the best fit line for a certain set of data. We have these dots everywhere, right? We have seen the dots everywhere. And the regression line, we draw a line through these dots and this line has to be in the middle of all the dots. Then the regression line makes the sum of the squares of the residuals smaller than for any other line. So what's the importance or what's the importance of this line? The difference between or the distance between this line and every dots has to be the minimum. So you have to draw a line like that. That's what the residuals mean, the difference between the dots to the lines. It has to be minimum. So you have to make a line exactly through the middle of all the dots. Then only you can reduce the residuals from the lines to the dots at minimum. So that line is what we call it as best fit line. And this is what actually a regression line is also. So regression minimizes the residuals. And here we are going to look at the formula for regression, how you can predict y by knowing x. So the formula that is used in regression analysis to calculate y, that is the expected value or dependent value for a given value of x that we call it as independent value, is y is equal to a plus bx plus e. Here what is y? Y is the dependent variable. Y is depending on advertisement, right? So here example, annual sales. What is annual sales? And x is what? The value of the independent variable, like advertisement or marketing cost, what you are going to do. Okay, now what is A? A is the amount of y when x is equal to 0. Or in our example we can say how much sales you will have when you don't do any advertisement. You will have at least some sales if you don't do advertisement, right? So what is that amount? So when there is no advertisement, how much you can sell? Then how much you are doing advertisement, that is what x is. Then what you will take, what is b? That is the slope of the line, also known as the regression coefficient. It represents the impact x has on y. This is what we calculated earlier. The relationship between x and y. That is what this b is. So every 1 unit change in x, y is expected to change by b units. When there is change in x, when there is change in advertisement, if you spend $1 in advertisement, the sales will increase by $10. I'm just giving an example. If the concept is that if you spend $1 in X or advertisement, Y is going to increase by $10. So that is what B means. Okay, B is the relationship. So you established a relationship between X and Y. So now you have a multiple of 10 here, and using this you can predict your future. So if you spend $1 of advertisement, you will increase your sales by $10. So that means if you can spend $100,000 in advertisement, your sales will increase by 1 million. Okay. The X is the value of the independent variable and E is the standard error of estimate. So we have seen that in direct relationship or positive relationship, when there is no perfect positive relationship, all the dots are not on the regression line. There are residuals, right? So that means there are errors in your formula. So average of that error is what we call it as E. But in most of your questions related to CMA, E will not be considered. It is going to be only Y is equal to A plus BX. So now you can find out Y if you know A. A is what? When A we call it as Y-intercept, or when X value is equal to 0, how much will be Y? That is what A means. If there is no advertisement, how much sales you will make? Then advertisement, how much, and what is the relationship between sales and advertisement? That is what we are going to do here. And that can be shown in this graph also. You can see here, this is the value of Y, this is the value of X. And when there is no advertisement, still you have a sale, right? So that is what we call it as Y-intercept. Okay, when there is no advertisement, still you have this much of sales. Then for every unit of advertisement, your sales are increasing. You can see here sales are increasing. So you can find out when advertisement is this much, your sale is going to be this much. So this is what we call it as Y-intercept, and this is what the difference or slope we can say here. The same formula you can use for finding out fixed cost and variable cost from the total cost. We have seen before in section B, right? In section B, how to calculate fixed cost and variable cost if you know the total number of units and the total cost. We used high-low method there. And during that time, I explained there is another method, that is regression analysis. So that also you can use to find out how much is the fixed cost and variable cost in the total cost. So here it is clearly visible here. If this is the total cost, we can say this is the fixed cost. Whatever you say your X is, your sale is always same. So that we call it as fixed cost. So whatever your production is, you have some cost that is fixed. So that is fixed cost. Then the variable cost, when you start making more and more unit, the variable cost is increasing. Correct? And that is what your total cost is. So you can find out the variable cost and fixed cost if you know the total cost from this graph. So the formula is Y is equal to A plus BX. So here, use of regression analysis. This is particularly valuable for budgeting and cost accounting purposes. And it is also useful to calculate fixed and variable cost portions of mixed cost for flexible budgeting. If you know the total cost and if you know the total number of units you are making, you can calculate how much is the fixed cost and how much is the variable cost. The y-axis intercept, that is what the fixed portion of the slope of the regression line in the variable portion. So that we have seen in this example. This is what your fixed cost is and this is what your variable cost is. So use of regression, we can see an example here. A firm can project the amount of revenue if it can spend on advertising $89,177. So you are going to spend $89,177 for the coming period. So considering this $89,177, how much sales you are going to have in the coming period? That is what we are going to find out. So here we can say the calculation of Y is going to be 4,200,000. This is the amount of sales you will have even if there is no advertisement at all. So it is going to be 4,200,000. Then you have your B here, that is what 311.741. That means if you spend $1 of advertisement, your sales will increase by 311.741. And X is the value of advertisement. So if you have these values, you can find out how much your sale is going to be. So 4.2 million plus 311.741 multiplied with 89,177. So you will get a total of 32 million. So if you spend 89,177 and every dollar you spend in advertisement is going to increase the sales by $311.7, your total sales you are going to have is going to be 32 million. So this is the use of regression analysis. Same like that, you can just rearrange the formula. We can say here I want to make $32 million. So how much advertisement I have to spend? So you can use same thing in this formula. A firm can project the amount it will have to spend on advertising to generate 32 million in sales. So how much advertisement you have to make? So here the answer we know, I want is Y is 32 million. I want 32 million sales. So Y we will keep it as 32 million. And A we know and B we know, X we have to find out. So 311.7X is going to be 27,800,000, which is 32 million minus 4.2 million. So X is going to be 27,800,000 divided by 311, or we can say it is going to be 89,177. So you can project your advertisement based on your expected or your target sales. Okay, so this is how you will do the calculation of Y knowing X using regression analysis. Also, you can have multiple regression analysis. So we have said that there is a relationship between sales and advertisement. But are you sure the sales are only depending on advertisement? No, there will be more other factors that is going to impact the sales. So what we have considered in the previous example is only one factor that is going to impact the sale. That is not real always. So there are more factors that is going to impact the sales. So in multiple regression, what we will do, we will take X1, X2, X3 and X4 up to Xn. These are all different factors. Maybe inflation, taste of the people, economy, everything is going to impact the sales. And their relationship also should be there for each of the values. So it is an extension of the simple regression. So here it is same Y is equal to A. Then you have multiple B and X. B1, X1, B2, X2. These are different factors and the relationship of each of these factors towards the sales. So this is we call it as multiple regression. So here we are discussing benefits of regression analysis. Benefits of regression analysis are, it is numerical and quantitative. This makes conclusion easier to draw. So you have seen the example, you are getting everything quantitative, right? So your conclusion can be easy. And it can use to forecast fixed and variable portions of the total cost. That also we discussed. The limitations of regression analysis. Historical data is required. If you don't have any historical data, you don't know what's the relationship between two variables. So you cannot use regression analysis. And also, if there have been changes in the environment or situation since the data was collected, we said till last year, the relationship between advertisement and sale is, say, 0.9. But this year situation changed. Maybe more competitors came into the market. Your share in the market is reduced. So you cannot expect same sales in the coming year by spending same amount of advertisement, because the environment is changed. So that is not considered in regression analysis. That's a limitation. And if the independent variable chosen is not appropriate, the resulting forecast may be invalid. So when there is a low correlation between independent variable and the dependent variable, your forecast can be invalid. There is no much relationship. So the factors what we are going to consider, that plays an important role in calculating the regression analysis. So maybe we can say advertisement have nothing to do with your sales, but you are using advertisement to forecast the sales. Or we can say you are choosing wrong variable. So when you are choosing wrong variable, your conclusion also going to be wrong. So that's the end of this presentation. Regression analysis. Thanks a lot for watching. Hope you understood everything, or hope you can understood everything who is going to watch this now or in the future. And thanks a lot for watching. Thank you for being with me. Bye-bye.